Today we're going to look at two special patterns for factoring polynomials. We're going to look at the sum of two cubes and the difference of two cubes. So to start off this lesson, I wanted to just go ahead and write out like the first 10 perfect cubes. Now, I know you guys aren't going to remember all of these, but maybe you'll remember like the first 4 or maybe the first 5, and that'll be helpful. We'll take care of if you forget what these are later on. But 1 cubed, so if you take 1 times 1 times 1, you get 1. 2 cubed, so 2 times 2 times 2. 3 cubed, so 3 times another 3. 4 cubed, 4 times 4 times 4. 5 times 5 times another 5. Okay, 6 times 6 times 6. Okay, let's say you're like, okay, that's starting to get too much for me. I can't do that in my head. Now, you know that you can take your 7, and remember this is your exponent button, so 7 cubed. Type that in, you get your 343. If I want to take 8 cubed, we get 512. 9 cubed, and again, I'm going to use this button in a minute, so that's why I'm showing you guys where your exponent button is. So 9 cubed gives us that 729. 10 cubed, 10 times another 10, 1,000. ... Okay, so if I ask you what number did we cube to get 343, you can say 7. Or you can also use the cube root button. So the cube root of 343 is 7. So that's saying what number did we cube to get 343? 7. On your calculator, if you want to check a number that they've given you, so for example, if I want to see is 216 a perfect cube, this was your exponent button for something other than a square. So this is going to be what we use for a cube root or a root other than a square root. Okay, so if I want to do a cube root, I have to type in 3, second exponent button. That tells my calculator that I want it to do the cube root of, let's do 216. Perfect number, so 216 is a perfect cube. So the cube root of 216 is 6. So if I ever give you guys a big number and you're like, I don't know if that's a perfect cube or not, grab your calculator and type that in. Those of you that have the graphers, you can go to math and you have a cube root button. And then you can type in your 216. Okay. If you get out a decimal, then that means that it's not a perfect cube and you'll want to try to do something else later on. All right, so we need to know perfect cubes because today's lesson is let's recognize like the sum of two cubes or the difference of two cubes. So if they give you the sum of two cubes, okay, so special pattern. So the first number is a perfect cube, they're adding, and the second number is a perfect cube. And again, if you're like, I don't know if those are perfect cubes, then you can use your calculator to see if those numbers come out to be nice whole numbers. But if you see that they are adding two cubes, the result is going to be a binomial times a trinomial. Okay. All right, so you're going to take the cube root of A and write that number down. You're going to put plus, then whatever this number is cubed, you'll write that down. So there's my binomial. Now my trinomial is almost like the perfect square trinomial. We're going to square the first term. Okay. However, they do a sign change. So if this is a plus, you're going to sign change, and then it's going to be the product of those two numbers. And then last, it's going to be the b squared. Okay. if they give you the difference of two squares. Okay, so not two squares, I'm sorry. I'm used to saying squares. Okay, cubes. Okay, so if they have an a cubed and they're subtracting another perfect cube, the result's still going to be a binomial times a trinomial. The binomial is going to be the cube root of these values. So if I cube root an a cubed, I'm going to get an a. Whatever the sign is, that's what I'm going to write. I'm going to take the cube root of this number. I'll put that here. There's my binomial. And again, I'm going to get a trinomial as a result. So I'm going to take this number and square it. Whatever the sign is, we're going to change it. We're going to do the product of those two numbers. And then the last term is always the b squared, and it'll always be positive. All right, one thing to keep in mind, the trinomial will never factor. Okay, so you don't have to worry about trying to factor that part or that part. Okay, let's look at some examples. Okay. So, what number do you cube to get an x cubed? X. What number do you cube to get 8? 2. Since it's a positive 2. Okay, the trinomial is this number squared, a sign change, multiply, square. And you don't have to worry, that will not factor, so you get to be done. Okay, let's try another one. Let's do m cubed plus 27. Okay, so what number cubed is m cubed? M. What number cubed is 27? That was the 3. Okay, now my trinomial square, sign change, product, square. And again, that will never factor. Okay, let's do 64x cubed minus 1. Okay, so what number do I cube to get a 64 and an x cubed? That would be a 4 and an x. Keep the sign. What number cubed is 1? 1. Okay. Square this. Sign change. Product. Square. And again, this will never factor. Okay, let's look at another one. Let's do a 4x to the 4th minus a 32x. 4 is not a perfect square. I'm sorry, not a perfect cube. Okay. But if I look at something, I notice that both of these terms, I can divide out a 4, and both of those terms have an x. So I'm going to factor out a monomial of 4x. And then let's see what we have left. So if I divide out a 4 and an x from here, that's going to give me x cubed. If I divide out a 4 and an x from there, that's going to leave me with a negative 8. Okay, so now I do have the difference of two perfect cubes. So we're going to say 4x. What number cubed is x cubed? X. What number cubed is 8? 2. And since it's a negative, we're going to leave it negative 2. Okay, now for the trinomial, square the first term, sign change, multiply, square the last term. Okay, and there's our final answer. Okay, let's try one more. Okay, let me give you one that's a little bit harder, okay? This is still the difference of two cubes. It just looks a little bit differently. You're not seeing the 3 as easily. But if you think of this, I could write this as a power to a power. So my goal is I want to have it as a cube. So if I had an x squared and then I cubed it, that would give me an x to the 6th. Okay, and then I've got what number cubed is 64, and that was our 4. Okay, so on this one, this is still the difference of two cubes. So what number do we cube to get an x to the 6th? That would be an x squared. What number do we cube to get the 64? That was the 4. Okay, so now we're going to write our trinomial. So we're going to square that. So an x squared times an x squared is an x to the 4th. Sign change, the product, and then we're going to square. Now, one thing that can happen, this is the difference of two squares. So this can now factor into x minus 2 and x plus 2. And you're expected to factor down completely. X to the 4th plus 4x squared plus 16. Okay, and that reminds me of an example from yesterday's lesson that I said that I would come back to. So we had a problem, and it was 27x to the 4th plus 54x cubed minus 64x minus 128. Okay, and we solved that by the grouping. So we grouped the first two terms, and then we grouped the last two terms. The common factor that we took out of that was a 27x cubed, and that left us with an x plus 2. Okay, I'm basically like undistributing when I factor out this. Okay, so 27x cubed times an x is the 27x to the 4th. 27x cubed times 2 is the 54x cubed. Out of these two terms, they're both divisible by negative 64. If I divide out the negative 64 from each term, that's going to leave me with an x plus 2. Here's my like term. So I'm going to say x plus 2. And then our other factor was what we pulled out. So the 27x cubed minus 64. Now, you should hopefully start to see that this is the difference of two perfect cubes. So, what number cubed is 27x cubed? 3x. What number cubed is 64? 4. Okay, so then I've got my binomial, so the trinomial is this squared. So 9x squared, sign change, the product, square, and then you still have that x plus 2 at the back. All right, we'll stop there for today.